Hello students, today we'll be doing the first problem based on variable acceleration. The question says the acceleration of a particle is defined by the relation a equals to minus 60 x raised to minus 1.5, which is in meter per second square. Knowing that particle starts from rest from a position x equals to 4 meter, find the velocity of the particle when the first condition x equals to 0.5 meter, the second condition x equals to 1.5 meter, third condition is position of a particle when velocity is 10 meter per second. So here the relation we'll start with. Very first part is your solution. The relation is your a is equals to minus 60 x raised to minus 1.5. This a can be written as v times of dv by dx, which is equivalent to minus 60 x raised to minus 1.5. Now the question is why we are doing this in the terms of dv by dx, because here it is x, and that's why this a is taken in the terms of x. Why is it so? Because v dv is equals to minus 60 x raised to minus 1.5 dx. Now we will take the integration on both the side. V dv is equals to minus times of integration 60 x raised to minus 1.5 dx. Now here this v will become v square by 2 equals to minus 60. This is your x raised to n, which can become, if the integration of x raised to n will take it, x raised to n plus 1 upon n plus 1 plus c. Why plus c? Because the integration doesn't have the limit. Now if you want to, I'll just mention it here. Integration of x raised to n dx is equals to x raised to n plus 1 upon n plus 1. This is the formula. Okay. Now if this I want to write it, then this can also be written as v square by 2 is equals to minus 60. Here this minus, which is your minus 0.5, and here it is becoming minus times of 0.5 plus c, which can also be written as this negative is cancelled, and here it becomes 0.5 means 120, because 1.5 is 1 by 2, 2 goes above 120, and x raised to minus half, which is actually a root of x plus c for v square by 2. I hope you are understanding it. Now to find out the value of c, we'll put the case. What is the case? If v is equals to 0 at x equals to 4 meter. Now what is this case? When you'll see the question, it is mentioned that the particle starts from rest and from position x equals to 4 meter, and that is the condition we are applying here. And if we'll apply this condition in the above equation, then it becomes 0 is equals to 120 by root 4 plus c, which will give us c is equals to minus 60. This is the value what we'll be getting. Now this value, if I'll substitute in this of the equation, then the general equation what I'll be getting, or a general expression, will be your v square by 2 is equals to 120 by root x minus 60. This is the equation what we are getting here. Let's take this equation as 1. Now here we have to find out all the conditions. X equals to 0.5, what is the velocity? X equals to 1.5, what is the velocity? And if the velocity is 10 meter per second, what is the position? So we'll start with, if x equals to 0.5 meter, then in this equation we'll substitute v square by 2 is equals to 120 by 0.5 minus 60. Now if we'll use this with the help of the calci, then here we'll be getting the terms of v is equals to 14.813 meter per second. Similarly, the next part, if x equals to 1.5 meter, then what is the case? V square by 2, 120 by 1.5 minus 60, which will give me again a v value will be your 8.716 meter per second. I hope you are understanding the problem. The last part of it is, if my velocity is 10 meter per second, then what is the condition? So here 10 square by 2 is equals to 120 by root x minus 60. That will give me x equals to 1.19 meter. With this, I hope you understood the problem. Thank you.